Hello, mathematicians, puzzlers, and other curious people. Today, because it's Pi Day, I'm going to talk about something to do with pi and circles. And what I'm going to talk about is a rumor that I've seen going around that there's something wrong with the formula for the area of a circle. So, you've probably seen before a bunch of times the formula A equals pi r squared. What people are saying is that this formula is too simplified to make sense. Now, here's why they're saying that. That's based on sort of the pizza slice principle proof. It's based on some limits, but you don't need to have taken a whole calculus class to get the idea. Here's my really crumbly drawn circle. And here is a radius of that circle. Now here's what might happen if we decided to pizza slice that circle. I'm going to do 8 slices. Now it's actually true that for this to completely go right, you would need to slice it an infinite amount of times. 8 is kind of enough to see what's going on, but because we're talking about limits, you have to use your imagination a little bit. That is just how that goes. So we have 8 slices in all. And we can line 4 of them up this way, kind of stretching them out. And then we can take the other 4 and fit them 3 in between and 1 at the end. Now I want to point out that this isn't exactly a rectangle, and this is where the imagination comes in. If you did narrower and narrower pizza slices, like 16ths, then they'd be skinnier and skinnier, closer to straight up and down. So like I said, a little bit of imagination can go a long way when we're talking about limits. So if we take that in our imaginations and continue it, that radius would show us the height of the rectangle, and its base would be, well, what we've got here is that circumference being split among these 4 and these 4. I know I sketched more in, but there were 4 here. So there's half the circumference, and there's half the circumference. And remember, in our imaginations, we're taking teenier and teenier little curves. So it makes like almost a straight line. So that would be, if we got a straight line out of it, that would be half the circumference. So then that gives us a way we would say, okay, well that area of the circle is half the circumference times the radius, just based on good old base times height. I guess you never knew, or maybe you did because you've seen this before, but a lot of people never knew how much like squares and rectangles are really in under all kinds of things. Well, that circumference, though, see, we don't like it if we have extra variables floating around, so we'd like to replace that circumference with something. So, you may already know, I'm going to be reposting a video from, I think it was last year, might have been the year before, that shed some light on this. But that circumference is pi times the diameter. So what we've really got is half times pi times the diameter times the radius. Well, what's that diameter really? And now I need to tidy this up. Well, a diameter is really a radius back to back with another radius. So that diameter is double the radius. So then we can copy in the rest of the formula around it. And we've got some different and equal, because we haven't changed any values, ways to say the same thing, that area is half times pi times 2 times the radius times the radius. Well, that's not real tidy. So one thing we might say is, well, half times 2 is just 1. 1 times anything doesn't change anything. So we can just take those out. Now another way we would probably tidy that up and say, well, the radius times the radius is just the radius squared. So then we would say, okay, the area is just pi times the radius squared. Good thing to know, it's a nice exact answer, as long as you believe in this in the first place. And so that here, all this simplifying that it takes for that radius squared to show up is why people are saying that radius squared doesn't really have much to do with the area of the circle. And that's where I've got to say they are not quite right. So I've prepared here a diagram in GeoGebra. I'm going to take this segment out for a moment. I'll put it back when I'm ready for it. Come on now, having a little trouble selecting. Come on. Okay, there you are. Don't need that segment right now. These things happen. Okay, so here is... by the way, this is the Linux app of GeoGebra rather than the web app, but it has pretty much the same features. So what I'm seeing is if we have a circle, so in this case its radius is about 1.5, but we can use the fact that GeoGebra is dynamic to say, okay, let's try 2 or 4 or 5. It's off the screen, but we can still visualize what it's doing over there. So we can see that we can also draw on a square off of the radius that adjusts itself, because of how it's drawn in GeoGebra, in proportion with the circle. So since these make a proportion, one thing we can conveniently say is, not that one now, this one, there we go. Since those are proportionate to each other, we can say that the area of the circle is some number times the radius squared. Now we already know, spoilers, that number is pi, but is there any good reason from the picture why it should be pi? It turns out there is. So I can give you at least a really good reason why that number would be between 2 and 4 very easily. So here is what happens if we draw out 4 of those radius squares. So you can see clearly that it covers the entire circle and more. So clearly 4 is too big for n. So we can say definitively that n is less than 4. Okay, but on the other hand, what if we cut that in half? So what if we said, okay, let's cut each square in half. So now we've got some little triangles that are completely contained within the circle, and some of the circle through here is spilling out. So half of 4 is less than the area. Well, half of 4 is 2. Or half of 4 radius squares is less than the area. Well, half of 4 would be 2. So 2 radius squares would be too small to be that area. So we know that this number that's closely related to the area of a circle, because it's the proportion between the radius square and the circle's area, has to be between 2 and 4. Well, you know what's between 2 and 4? Pi, which is 3.1415 blah, 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 etc. I used to know more digits, haven't used them in a while, don't want to say something wrong. The point is, we see that this number that's a little more than 3 fits really nicely into this range that we can see from the picture, having something to do with that circle. So I'm here to say, in defense of this formula of a circle, that the radius squared does clearly have something to do with it, and we can see how it actually makes some sense. It's not just a simplification of the other one. So this was an example of how you can use GeoGebra to investigate and demonstrate things about geometric figures. Now, have some fun with checking out geometry in other ways. Enjoy some Pi for Pi Day if it's not already over for you. If it is, hey, 3.1416. Well, let's see. any day is really a rounding error close to pi for a little while here. So enjoy some rounding error pi tomorrow if you're just if you're late seeing this video. And other than that, I will calc you later.